Buse, and today, as she told, we will try to share our experiences to you about the automation environments and frameworks.
Okay, in our agenda today, we will start with an introduction about the software under test and our test automation environment. Then we will try to define the test smells and the different types of test smells. Finally, we are going to provide you our solutions to prevent those test smells.
Yeah, we will start with some introductory information. First of all, we will talk about the system under test in the study and our automation environment. We will talk about this just to give some insights about the environment in which we are working and the environment in which we are developing our test cases. But normally what we talk about the test smells and the solutions against them, which we applied, are not case-specific situations. They can be applied in any automation framework. But as I told, just to give some insights about the visualization of the environment, we will talk about this. So the system under test in the study is MindSphere, which is a cloud-based open IoT platform. And you can connect your devices from your manufacturing fields to the cloud. And over sensors, you can collect data and upload them to the cloud. And in this way, you can monitor them, store them, and manage your data. And even you can use this platform as a development platform as well. You can do all this by using the open APIs and UIs of the system. And this is a big project developed by more than 600 developers in globally distributed sites. It has a big scope. And for the testing purposes, it has actually two main aspects of the approach. The first one is the API testing side, and the next one is the UI testing side. Uh, Especially for API testing, the internal structure of the system is very important. It's a pretty lovely product from outside, but inside it has a complex structure. The architecture is built upon microservices concept. And in this point, the working principles are very important because those microservices are working independently and asynchronously. That's very important for testing purposes because sometimes it causes for extra difficulties and challenges for testing. We will talk about those test smells stemming from this structure of the system. And then we have the UI testing part as well. For UI side, we have some different challenges. For example, the stability and robustness of the system is affected from the aspects of the UI pages and web pages. For example, sometimes the element IDs can be changed by the developers, or sometimes the waiting times can lead us to misunderstandings or some wrong results. So we will talk about all these by sharing our solutions against them. And this is the our test automation environment. We develop and implement our test cases to automate them, and in this way we can automatically execute them in our pipelines. We have a pipeline in which we can trigger or schedule our jobs, and in this way we can execute our jobs nightly. In each night we can run our test cases, and after each execution we can report our test results, including the details of the execution. For example, we include the evidences and logs of the executions as well, and we report all those to the our test management systems. For example, in our case, we use Jira as the test management platform, and we use X-Ray, which is a plugin of Jira, to manage the test results and test cases. So we use GitLab CI Runner for the main pipeline. And over that, we create some virtual environments to execute our test cases. And finally, as I told, we report test cases. And for the main test implementation environment, we use mainly Java language, but of course, we make use of some different platforms and frameworks and libraries as well. For example, for our API side, we use a Java Jersey client library. And for UI, we use Selenium framework and Gargoyle software libraries. And in this way, we can execute our UI cases both in headed mode and headless mode as well. And we use some other libraries or frameworks such as TestNG for the main testing framework, or Allure for reporting, and Mockito for unit testing. So this is the picture of the whole automation environment.
Okay, so what is a test smell? So a test smell is a symptom underlying in the test code which indicates a deeper problem. We can also say that test smells are poorly, weakly designed tests, which will eventually affect the quality of the production code. So they shouldn't be ignored because they are only the problems in the test code and not in the development or production code. Because if they are not fixed on time, they may cause very serious and critical problems. So let's see some examples of it. So they may cause some silent error cases where our test code is not effectively testing the product because of a test smell it has. So in this case, we may possibly miss a defect in the earlier stages of the development cycle, and the defect can even go to the production code and to the customer. So as you see here on the graph on the left, the later we detect the defect, the cost to resolve the defect will be a lot more high. So they may also cause some false alarms. In this case, so the software under test is working as expected. However, because of a test smell in the test code, some of our tests are reported as failed, and we thought that there is a problem in the software under test. And it may require a considerable analysis effort, especially for testers, which is actually for nothing because there is no actual bug in the system. So let's see a real example of this. Sorry, it also may mislead the users. So let's see an example of this. So at the right, on the picture on the right, you see a beautiful picture of an aircraft right before it crashed and killed 121 passengers and the crew on board. So in this case, at that time, the pilots were getting too many false warnings from the airplane system, and eventually they ignored the real one. And finally, unfortunately, because of this real warning which is ignored, this accident happened. So as you see here in the table, in literature, there are too many different types of testimonials, which are grouped under different categories. But today, we want to go over the ones that we face most frequently in our test automation environment. So let's try to define them very shortly. So one of our biggest pain points were flaky tests. So a flaky test is a test having inconsistent test results because of a test smell it has, because of the way we implemented the test code. So if you check the history of a flaky test, you are going to see some uh, inconsistent test results. You are going to see some passes and some fails, and there is no actual reason behind those fails. We also face with some suite-dependent tests, where a suite-dependent test is a test having different results when you execute them independently or within a test suite. We also face with some fragile tests, where a fragile test is a test having inconsistent test results when we change the test input. So another group was distortive testimonials. So these are the ones causing silent errors or false alarms because of wrong assertions and bad mocking. So we also face with the limited scope problem, where our test results are changing when we change or extend the test scope. And finally, we face with some problems because of the structure of our test codes.
Yeah, as Buse mentioned, there are lots of testimonials, and actually, if you perform a survey on the literature, you will find more than maybe 100 types of testimonials. And as she told, they can cause to really critical problems and situations. So when we regard the situation, it looks very scary, but it doesn't mean that there are nothing to do against them. There are some solutions which can be applied against them to overcome them. So we will talk about the the solutions one by one. In our cases, the most commonly test SMAs, we applied some solutions. Firstly, let me introduce the story lying in the background of this application of solutions. Normally, our team is responsible for the implementation of test cases, the development of the test cases. But in some point, we realized that we are blocked from those tasks with some other tasks. For example, we had too many maintenance tasks, and we had to analyze the failing tests. So we started to think about the reasons behind that. I mean, why we had too many frequently failing test cases, and why we had too many analysis efforts to analyze the results and analyze the logs of the executions. So we started to investigate all the root causes, and we started to list the test symbols which were causing these problems and these situations. And then one by one to those symbols and root causes of the symbols, we started to apply our solutions. So this is the table which summarizes the problems in a categorical view. Actually, we have three major categories of problems. The first one is, as I told, the maintenance efforts, which were blocking us from the implementation tasks. The second one is the escape bugs, which means we could not find in time. And those are the bugs coming from the customer side. So it is not a desired situation, because when we do not catch the bugs in time, then it will lead to some extra costs, and maybe it would be too late to apply our fixes against them. So catching the bug in time is really important in this manner. And the last category of our problems is the refactoring efforts related to the code quality in our test framework. And we found the test summas causing these situations. Those are the flaky tests, scope-related tests, and structural code quality summas. And we find the root causes, and we try to develop some solutions. So I will start with the first one, the flaky tests. When we investigate about the root causes of flaky tests, we found that asynchronous waits are the most probable cause for that. And we can see a graph on the slide which supports our claim. It is performed by some scientists in the literature. And an asynchronous wait is a request which does not wait for the response properly. I mean, when you send a request to the cloud or to the services, when you get the first response, it doesn't mean that the whole transaction is completed. So what you have to do is to really ensure that the operation is fully completed. For instance, when I send a creation object request, then I can get a 200 response, which means a successful response, but I still do not know the object is created, because 200 means that my request is not an unauthorized one. It is not 403, or it is not in a bad format. It is not 400. It is a successful request, but I don't know still if the object is created. So what I should do is I have to ensure that the object is really created. So I will illustrate this over a code scenario. And in this one, I send my creation object request, and then I check for the result. And this is just a simulation. So the object creation method is just waiting for 5 seconds, sleeping, and then creates the object. This is just a simulation code. And then what I do is I'm polling for the expected result in a frequency with an interval frequency. It is 1 second. So in this case, each second I poll for the expected result, and whenever I get the expected result, then I set the test case to pass situation. Otherwise, even if I wait for the maximum acceptable waiting time, if I still do not get the desired response, then my test result would be failed. So with the help of this polling mechanism, I can properly wait for the response. Otherwise, if I would send the assertion request just after the create object request, then I would face a failure case, because on that time, the object would not be created. Because normally, a object creation service is a black box for me. I don't know when exactly the object will be created. So if I immediately send my assertion request, then it would be a fail. But in this case, after 5 seconds, since I'm polling it with a frequency, then I reach to the expected result after a while. And you can see here how it helps. On the right side, it is the results without polling mechanisms, without retry mechanisms. And on the left, after we apply it, it shows that how it helped. On the same number of executions, instead of 6 or 7 failures, we had only one, or in some situations, even we face with no failures stemming from the test code. After polling mechanisms, another solution we applied is the cleanup mechanisms adapted in the test framework, and it eliminates the conflicts between consecutive executions, because normally, if we do not delete the objects that we create, then it can cause to some conflicts for the next run. And in this way, we adapted some cleanup codes in the framework, and we eliminated the unnecessary load in the system. And additionally, we reduce the risk of conflicts between consecutive runs. We make use of after methods coming from a TestNG framework. And even if in the unexpected failing cases, this method is triggered and all the objects created until that time are deleted in this way.
As Mesut explained before, we are responsible for testing microservices of the system. So even if the microservices are independent from each other, even if they are granularly deployed and working asynchronously, there may still be an order which we need to follow, which the services should be called, because uh, the data, for example, created from a microservice can affect another one. So we had the same problem. So we needed to control the execution order of our test cases. So for that purpose, we decided to utilize test annotations. So we defined some test groups, which are customized for us, of course, to represent, for example, the priority of the test cases, the type of the test cases, whether it's an end-to-end test or UI test, the covered features by the test case, or the responsible test side of the test case. So we define some test groups and we label our test cases with those annotations. So as you see here, we have different annotations which we label one of our test cases. So by doing this, we are able to execute the test groups that we want to execute, or we can control the order of our test cases. So one solution that we used to detect our flaky tests was keeping track of the test history. Actually, it is really easy if you are using a test management tool or a CI/CD tool to trigger your test cases and save your test results, because most of those tools are already providing that kind of functionalities. Like they save the historical results of your tests. So we basically did the same. We are also using some test management tools and CI/CD tools. We automatically send our test results to those tools at the end of our executions, and then we just utilize the functionalities of those tools. As you see here, even many of them are providing some graphical representations of the test results where you can see the trend in your test results. So we just keep an eye on the trend of our test results. We detect the test having flaky test results, and we assume that maybe there's a stability problem in those test cases, and we create some maintenance tasks for those test cases to make them more robust and to prevent that kind of fluctuating test results. So, and how we do it, we basically utilize the open APIs of X-Ray. So X-Ray is our test management tool. So as you see here, at the end of the execution of our test suites, we just post our test results to X-Ray by using the open APIs of X-Ray. and we easily store our test results there. We also put some additional information in our test results. So for example, here on test success method, in the comment variable, we save the build ID that we get from Jenkins, uh, which is the job triggers the test case. So when we have a failure and when we want to investigate the reason of the failure, it is really easy because we already have the build URL from Jenkins, and we very easily reach the logs related with this execution.
Okay, so those were the solutions which we applied against the maintenance efforts and the test smells causing those problems. And now I will start to talk about the second major category, which is the escape bugs coming from the customers. And as I told in the beginning, it is not a desired situation. So we started to think about the reasons causing these situations, because normally we were executing the test cases and which covers all the features and the functionalities in the system. So why we had some bugs coming from customers? Because normally all the test cases were supposed to cover the features. So what we noticed in that point is some of the customers were using some different environments than we did for testing purposes. And we understood that running the test cases on a limited number of test environment was not sufficient to fully ensure the whole functionality. So what we had to do is, as a decision, was to execute the test cases on different environments. For example, we have some hardware cases. So for those, we had to execute our test cases in different variations and combinations of hardware versions or operating systems. So for this purpose, we developed a machine manager server, which provides you some different combinations of environments, execution environments. And for UI cases, for example, we developed a Selenium grid, which provides you all the supported browsers. Instead of running the test case in a certain browser, we executed the test cases on all supported browsers. So in this way, we reduced the risk of bugs stemming from the variations of execution environments. And similarly, for the test inputs, we understood that running the test case with a certain data type or data value is not sufficient or was not sufficient for to fully ensure the whole functionality. For instance, when I check a feature, data upload feature with an integer value, it doesn't mean that it will again work with a string value. So what I should do is to execute the test case with all supported data types and with different range of data values. So what we did is to create a data pool, and instead of some embedded numbers, magic numbers in the test framework, we executed the test case over these test data pools. And in the data pool, we included all the supported data types with different data values, including corner cases, boundary values, negative cases, and enriched range of data inputs. So in this way, we reduced the bugs stemming from the variations of execution environments and different data inputs.
Okay, most of us probably are working in agile environments. So in this kind of environments, it is inevitable to have some updates on the business requirements. So in this case, of course, we need to update the development code to fulfill the requirements coming from the customers, but we also need to update the test code to be able to test the update in a correct way. However, this may be very cumbersome and time consuming. So let's try to define the problem over an example. So here on the wall, you see there are two Mona Lisa pictures. So if I, as a customer, want a bigger smile on Mona Lisa's face, the painter should go through each Mona Lisa picture and should repaint both. So in this case, maybe it's okay because the effort is duplicated. But what if we would have thousands of Mona Lisa pictures on the wall? So it would be very time consuming for the painter, right? So we had the same problem in our test codes. So as we are responsible for testing end-to-end scenarios of the system, we have too many duplicated test steps in our test cases. And when there is an update in one of those common test steps, it was very time consuming. It was requiring an incredible effort to go through each test case and update them one by one. And especially when we consider we have more than 500 test cases. So in order to overcome this challenge, we decided to create some helper classes and move those duplicated code steps, test steps, to the helper classes and utilize them from the test cases. So let's see a real code example about how we do it. So in the before part, you see an entity creation operation. So at first, we create an entity and we set the required parameters for that entity. Then we call the post endpoint from a service to create the entity. And finally, we have the assertion where we verify that the entity is created successfully. So as you see, it requires too many lines of code. And if there is an update, let's say we want to add a new parameter to the entity. We want to set a new parameter according to the entity type that the entity has. Or as you see here in the validation part, in the at most variable, there is a time limit for the entity creation operation to be completed, which is actually coming from a business requirement as well. So what happens when customer wants to shorten this completion time? What happens we want to set it to 1 minute rather than 2 minutes? So it would be very hard if we needed to go through each test case and update them one by one. So rather than doing this, we just take this code block and we move it to a helper class. So after the move, as you see here in the after part, it is only one line of code for the test case. So when there is an update, we just go to the helper class, we update the related test step, and none of our test cases are affected from this change. So even if what we develop is a test code, code quality, of course, is still very important because as the quality gets higher, the possibility to have a test smell in the test code will be much lower. In order to increase the quality of our test code, we define two-stage peer reviews. So in the first stage, we review the test scenario, we review the test steps. So we ask questions like whether those test steps are related with the test goal. Do we have any eager test steps in the test design? Or are the test input and the expected results complete? And so on. So after we finish the test design review, we switch to the code review, where we not only do a static code analysis, but we also encourage the tester to use the helper classes. Even if the helper classes does not provide the functionality, does not provide the needed test steps, we encourage the tester to implement those steps to the helper classes and utilize them from the test code. So for this purpose, we also make use of some tools. In our case, we are using SonarQube. So in SonarQube, we define our quality rules and we integrate SonarQube into our CI pipeline. So when there is a new merge request, our SonarQube jobs are triggered automatically by our pipeline, and the test code is analyzed according to the rules defined in SonarQube. So if the rules are followed, we allow this test code to be merged into the main line.
And last but not least, we will talk about some additional supportive automation steps. These are not the one-to-one solutions against test emails, but this can help with the automation of some manual steps. For example, the first one is the monitoring of the issues. For example, normally we can check and track the issues and the progress on the issues on Jira with queries, which can be performed found on the UI pages and web pages of Jira. And in this way, we can go to the website and the URL of the Jira and create some queries over the web page and filter the results and parse some results over the response. But it is a manual effort, and it means some cost and time in terms of the project manners. So instead of doing all these manually, we can execute some codes to make all these queries and parse the related values over the responses. So in the slide, we can see an example code for that. We create a query to get a response, related response for our search. And then over the response, for example, in this scenario, we parse the creation date of the issues and resolution date of the issues. So subtracting one from the other one, we can reach to the resolution duration of the issues. So we can make some insights over this response. And for example, if some of the features collected on a certain feature is not resolved in a certain time, then we can make a feedback to the related responsible team or responsible person of the feature. Or otherwise, if some issues over a certain feature is resolved in a certain time, quickly, in a short time, then we can make a feedback over those features. So we can make some related insights over these queries automatically and periodically without any manual effort. Another thing that we would advise is to usage of storage services. For example, in our case, we use Amazon S3 buckets and we use S3 services. For example, we have some test inputs and test outputs as well. For example, we use some large data files to be uploaded to the cloud services. So storing them and managing them in our local environments is very difficult, and it can cause some maintenance efforts. So what we do is we store them in the S3 buckets, and in each execution, we send a request to get those files and then proceed with the next test steps. And similarly for the test outputs, for example, in our failing UI cases, we do not want to lose the screenshot of the failing point. So what we do is we capture the screen in which point the test fails. Then we upload those screenshots to our buckets by using of these S3 service codes. S3 bucket codes. And the last one that we would advise as an additional automation step is to creation of some dashboards and graphs about the environments. For instance, if I want to give a real example in our case, the assets numbers, the asset counts in our environments were of critical importance. So what we did is we created some dashboards and graphs on our monitoring tools to visualize what's going on in the environment, in our environment. And if some limits are reached out, then some warnings and alerts were sending to us to be aware of the situation in our environments. And this is the code about how we do this. We parse some metrics from our environments and we upload them to Amazon CloudWatch services, and then we can transform them to other monitoring tools or platforms such as Grafana, or even on the CloudWatch services, we can create some dashboards. And by visualizing the metrics, we can better understand what's going on in the environments, and we can be aware of all the metrics about the environmental variables.
So once again, we wanted to show you the table where we map our problems that we have because of specific types of testimonials with our solutions that we developed against them. So of course, these solutions are addressing our own problems, but we thought that if you are also facing similar problems, maybe these solutions can be helpful for you. or at least they can give you some ideas to develop your own solutions for your own testimonials. So, as a last sentence, our call for action is please be aware of your testimonials and develop your own solutions to prevent them. Thank you for listening.
Thank you for listening.
So let's check whether we have any questions.
Yeah, I think currently we don't have.
Yes, I don't see any.
Yeah, just wait for a while
Okay,
if there will be,
maybe.
and then we can finish. I think we won't have any, so I hope everything is clear, and you can reach out us for any
Of course,
recommendations or questions later on.
of course, of course.
Thank you.
Thank you again.
Bye bye.